Welcome to a new video. Today we are going to talk about hyperparameter tuning using Gridsearch. Gridsearch is an exhaustive search technique that we use to find the best parameters for our machine learning model. So what exactly is hyperparameter tuning? Well, hyperparameters are settings in the algorithm that can be adjusted to optimize performance. Hyperparameter tuning is the process of systematically choosing the best hyperparameters for your model. The best hyperparameters are the ones that produce the most accurate model on a validation set that the model has not seen before. So let's import our libraries and directly start. We are going to import NumPy, pandas, and we will import train test split from sklearn, model selection, import train test split, and we will import support vector classifier, support vector machines, import support vector classifier, and we will import the grid search, of course. Model selection, import grid search cross validation. Here it is. Alright, I just imported the libraries that we will need for this tutorial. We have NumPy for numerical operations, pandas for data manipulation, and some modules from scikit-learn for machine learning. Let's create a synthetic dataset for demonstration. We will say x numpy.random.rand 102 features, and then we will say x, let's say like this, and give 0 here. Then we are going to take this and let's say 1 in here, and let's say if greater than 1, and we'll use as type integer. So let's check them one by one. X, we have an array, great. Y, great. So we created a nice classification problem. Here I created a dataset X with 100 samples and 2 features. The target variable is Y, set to 1 if the sum of 2 features is greater than 1, otherwise it's set to 0. Before performing hyperparameter tuning, let's split our dataset into training and test sets. So in this way we can evaluate its performance. We will say xtrain, xtest, also I'm going to use capital letter, ytrain, ytest, and we will use train test split x, y, and let's set test size as 20%. Great. I just split our dataset into training and testing sets. We will use the 80% of the data for training and 20% for the testing. Now that we have our data ready, let's dive into grid search. We will use the support vector classifier as our machine learning model for demonstration. Support vector classifier has a few hyperparameters that we can tune, such as C and kernel. I'm not going to show all of them, but you can just search them in Google and add others if you want. We are going to define something like parameter grid, and we will say we are going to open a dictionary. C, we will give the values of 0.1, 1, 10, and 100. And then I'm going to say kernel, and let's say linear and RBF. Also, I need to add this into here, and now it's working. Great. Now we are going to create the grid search cross-validation object. We will say grid search. We will say grid search cross-validation. Firstly, we will give the classifier we have, then we will give the parameters grid, and then we will give cross-validation as, let's say, 5 in here. Now we are going to fit this into our data. We will say grid search.fit, and we are going to fit this into our training data, ytrain, and we are going to run it. Great, let's see the best parameters. We will say best parameters, grid search.best parameters, and let's print this like use f-string best parameters and use best parameters here. So you can see that our C is 10 and kernel is linear. That were the best performing ones. And let's evaluate this on the test set. Score grid search.score xtest and ytest, and let's print this like test score with best parameters, and we will say score here. These two commands print out the best hyperparameters found during the grid search, as well as the test score using those parameters. Great, we have covered how to do hyperparameter tuning for support vector classifier using Gridsearch. But let's not stop there. What if you want to tune hyperparameters for a different algorithm? Process is similar, but you need to change the parameters underscore grid. Like I'm just going to show you here. You need to change this one, because every algorithm uses different parameters. Let's do hyperparameter tuning for, let's say, random forests. Random forests are an ensemble learning method that can be used for both classification and regression tasks. They are particularly useful for handling high-dimensional data and preventing overfitting. So let's see how we can tune its parameters using Gridsearch. We will say from sklearn.ensemble import random forest classifier. Here we have imported random forest classifier from scikit-learn's ensemble module. Just like we did in support vector classifier, let's define a parameter grid for random forests and then use Gridsearch to find the best hyperparameters. Let's say parameter grid random forest. We will say number of estimators and let's give 10, 50, 100 and 200. Then we will say max depth. We can say none, 10, 20 and 30, and let's create one more like minimum samples split, and let's say 2, 5 and 10 for that. Now let's create a Gridsearch cross-validation object for random forest. We will say Gridsearch random forest and we will do Gridsearch cross-validation, our classifier here like this. Then we are going to do parameter grid random forest and let's set cross-validation as 5. Let's fit the random forest model. Gridsearch random forest dot fit xtrain and ytrain. We are fitting our Gridsearch object with the training data. In this code we have set up a parameter grid for the random forest algorithm, including number of estimators, max depth and minimum samples split. Then we fit the Gridsearch object with our training data, just like we did before. After running the Gridsearch, let's evaluate our random forest model with the best parameters on the test set. Let's say best parameters random forest and Gridsearch random forest best parameters. Let's select that and print this like best parameters for random forest, and we will do best parameters random forest. 20 for max depth, 5 for minimum sample split and 50 for number of estimators. Now let's evaluate this. Let's say score random forest and Gridsearch random forest dot score. We will give the testing data here, ytest, and we are going to print test score with best parameters for random forests score random forest. Great, it's 0.9. By the way, support vector classifier performed way better. You can try all algorithms and pick the best performing one. That was all for this video. Thanks for watching. I'm creating content about data science and programming. You can subscribe to my channel for more. Have a great day.